Hey everyone, Mr. Regan here, and today we are starting off our lesson looking at some collisions in our sim and focusing on this idea of if two objects collide, how do the forces affect the objects? Up to this point, we've been exploring that during a collision, we know that forces act a certain way, but today we're looking at how do the forces then affect the object, considering we've seen so many different outcomes with all the different experiments and sim missions that we've run up to this point. So, as of today, we know that when two objects collide, we know that a force is exerted on each object. The two forces are exerted in the opposite direction, but they are of equal strength. So, for example, in this image below, we have two objects. When they collide, you'll notice that the forces are equal and in opposite directions. Well, why is it we have so many different variations of what happens to the objects when they collide? Sometimes they're starting their movement, sometimes they're stopping their movement, sometimes they're speeding up, slowing down. It all depends. Sometimes they change directions, sometimes they stay in the same direction. Why is it that we have the same forces acting on different objects, but we have all of these different reactions, all these different effects from these same exact forces? So today we're going to be really diving in and exploring that, starting with a little sim activity. In our sim activity, you're going to have two objects, object A and object B, and you're going to be making them collide. Now, when you make them collide, you're going to start by making a prediction. Do you predict that both these objects will change their velocity in the sim collision test when they collide? So that means whatever their starting value is when they collide, both of their velocities are going to change after the collision. Do you predict that one of the objects will change their velocity during the test when they collide? Or do you predict that neither of them will change their velocity when they collide? You're going to start by making a prediction, and then you're going to run three tests, test 1, 2, and 3. Each one will have A with the same starting value of 5 centimeters to the right. B will be changing as you collide the objects. Your job will be to look at the data table to look at the velocity change for your objects. If you don't know what that is, you can click on the help button. The velocity data change would be the change column we see here on the side for objects A and B. Now, once you get those change values for each of your trials, 1, 2, and 3, you're going to use that to begin explaining why is it that the same force can affect two colliding objects in different ways. So take a moment and ask yourself, do you understand how to make your prediction about the change in velocity of our colliding objects? Do you understand how to run and record the sim data to determine if your prediction was correct? Take a moment, fill out the survey. If you put your X in yellow or red, reach out, and as always, good luck.